Good morning students, welcome to online classes. In previous session we have discussed properties of determinant. So in this session we have discussed how to apply these properties. So here we take some examples and how to apply these properties. So in this determinant chapter, here we have a questions expanding and without expanding. So what do you mean by expanding and what is without expanding? First we have to understand expanding method or without expanding method. Expanding method means suppose we have a determinant 2, 4 and 5, 10. So we expand, it is a second order determinant. If we expand, then as you know in second order determinant how to expand, that is 2 into 10, that is 2 into 10, that is 20 minus 4 into 5, that is also 20, and that is equal to 0. So it is a procedure in expanding. But what do you mean by without expanding? If we solve this problem without expanding means we have to apply these properties. In previous session we have discussed 6 number of properties. So without expanding means take same examples. That means without expanding means we have to apply properties only. If we directly expand, then the answer is wrong. So we have to apply properties here because we have to find out without expanding method. So in this problem we take some constant, that means we take taking common 2 from first row. So we take 2 common for first row, that is we can get 1, 2. Similarly, we can take common from 5 from second row, that means 1. So according to properties, I think properties number 3 is if any 2 rows or any 2 columns are same, the determinant will be vanished or 0. So in this determinant you have seen first row and second row are same, so you can directly write it 0 because here R1 is equal to R. So this is the 2 methods, that is expanding method and without expanding method, to solve the same problem. But if you have to find out without expanding method, that means we have to calculate or you can be apply only properties only. You cannot directly expand them. So we take some examples here. First we have to understand what is expanding and without expanding. So take an examples. Question number 1. Without expanding, evaluate determinant of sin square theta, cos square theta 1, cos square theta, sin square theta 1, minus 8, tan 2. So here are questions and a question being without expanding methods. So we have to evaluate or we have to calculate. So the solution is, first we write a determinant, given determinant, that is sin square theta, cos square theta 1, cos square theta, sin square theta 1, minus 8, tan 2. So first we have to, as without expanding method means we have to apply properties of determinant. So here in this problem, first we have to check any taking commons from any rows or column. First we have to check. Here is no commons, any rows and can take commons from no, and no elements or no constant we have to commons in this determinant. So here we can add them. Suppose we apply this formula, as you know, sin square theta plus cos square theta is equal to 1. So we add any two rows or any two columns. That means if we add R1 and R2, then we have a formula, and the formula is sin square theta plus cos square theta. And as you know, the value of sin square theta plus cos square theta is equal to 1. So here we can write, suppose we can add R1 and R2. We can add first column or second column. We can evaluate row wise or column wise. So we take suppose column wise. Suppose in column 1, we add column 1 plus column 2. Why we add column 1 and column 2? Because column 1 and column, if we add column 1 and column 2, we have sin square theta plus cos square theta, and sin square theta plus cos square theta is equal to 1. So in places of column 1, we have to add column 1 plus column 2. So we take sin square theta plus cos square theta, cos square theta plus sin square theta, minus 8 plus 10 in column 1 places. In column 2, can be written in same, that is because we have to formulate a formula in column 1 places. So in column 1, we have to add column 1 and column 2. Okay. Now, if we apply formula, that means sin square theta plus cos square, as you know, sin square plus cos square is equal to 1. So we can write here 1, and it also 1, and that is 2. That is cos square theta, and remaining same because we cannot only write the column 2 and column 3. 1, 1, 2. So here, if we calculate them in this determinant, you can write directly 0. Why? Because here, according to properties number 3, column 1 and column 3 are same. So this is the reason to write directly 0, because in this determinant, column 1 and column 3, all the elements of column 1 and column 3 are same. So if, as we have known, if any two rows or columns of a determinant are identical or same, then the determinant will be 0. So the solution of this question is 0. Okay. Now take another examples. Suppose 1 by A, 1 by B, 1 by C. In the first column 1 by A, 1 by B, 1 by C. A, B, C, and second column. In third column, B, C, CA, and AB. So here, in this question, without expanding, we have to evaluate or we have to calculate. So first we have to write the given questions. Here 1 by A, 1A, B, C, 1 by B, second row is 1 by B, B, C, A. Third row is 1 by C, C. If you directly expand, you can get the result. But here, in questions without expanding means we have to apply properties. Okay. So here we apply. So which properties you have to apply? So you think that if we multiple A in first row, then you get the term here ABC, because A is missing. If A multiple, then you get ABC. Similarly, here B is missing. If we multiple B, then it will get ABC. Similarly, if we multiple C in third row, then you can get ABC. Okay. So here in first row we multiple A. Here A square, and that is ABC. Why multiple A in first row? Because A is missing. As we multiple A in first row, then here the value is ABC. Similarly, in second row ABC. So I think that if any rows or any columns are same, we have to calculate easily. So here in first row we multiple A in A multiple in first row. If we multiple A, then we have to divide A also. So here we write 1 by A because A is multiple and A is divided. Okay. Similarly, in second row we have to multiple B. So 1 by B into B, that is B square, and this is also ABC. Similarly, if we multiple C, then we get 1 by C into C, C square, ABC. So here if we multiple B in second row, then we have to divide it also. And similarly, as we multiple C in third row, we have to divide also C. As A is multiple, A is divide. So similar in the second row and third row. As you can write in right side that we have to multiple A and divide A also. Okay. So here if we multiple them, then we get ABC. Okay. And if we solve them, then you get here cancel A. So you get 1 A square ABC. Okay. And it's also 1 B square ABC. And it will be 1 C square ABC. So here you can see in this determinant ABC, ABC, ABC in all the elements are same in column 3. So we take common ABC from column 3. So 1 by ABC. So we take common ABC from column 3. As you know, we take common in determinant any rows or column. So here we take common ABC from column 3. So here first column is same, second column is also S square is plus C square. As we common ABC from column 3, so we get 1, 1, 1. As you know, any determinant, any two rows or columns having same or identical, the determinant will be 0 according to property number 3. So here you can symbolize that equal this determinant will be 0. So here the determinant is 0. The reason is column 1 is equal to column 3. As column 1 is equal to column 3, all the elements of column 1 and column 3 are same. So the determinant will be 0. So if the determinant is 0, then answer is also 0. Because any number is multiplied with 0, that means it's 0. So the solution of this determinant will be 0. Next, proceed to another examples. And these questions contain 4 marks according to CSC board. So here another examples: minus cos x square theta, cot square theta, minus 1, sec square theta, minus tan square theta, 1, minus 0.2, 1.2 and 1. So it also we evaluate or we calculate without expanding method. That means we have to apply properties only. Okay. So in this session we have to know, we have to learn how properties are applied in questions. Okay, so here you see question is minus cosec square theta, cot square theta minus 1, sec square theta minus tan square theta, 1 minus 0.2, 1.21. As you see, in this question we cannot take commons to any rows or columns. So you can see in first row nothing to come, in second row and third row also. Okay. So here any rows or column we have to add to have a formula. So here if we add, because we have now cosec square related to cot square, not sec square, so we have to add row or columns. First we have to think. So here see that if we add first row and second row, then here the relation between them, because cosec square is related to cot square and sec square is also related to tan square. So here in these questions we have to add, suppose R1, in places of R1 we have to add R1 plus R2, because the relation cosec square and cot square are related. So in R1 places we have to add R1 and R2. So here is R1 and this is R2. So you have to add them. That means minus cosec square theta plus cot square theta. Okay. And here sec square theta minus tan square theta. And here minus 0.2 plus 1.2. But R2 are same, because we have to add R1 and R2 in R1 places. So in R1 places we have to add R1 and R2. R2 are remaining same according to positions, and R3 is also same. Okay. Now here you can see, if we, as you know, the formula of cosec square related to cot square is, you know, cosec square theta minus cot square theta is equal to 1, as you know, in first year trigonometry, according to trigonometry. But here minus cosec square theta plus cot square theta. So here we talk, if we take common negative or minus 1, if we take common minus, so that is, if we multiple minus in this formula, then we get minus cosec square theta plus cot square theta is equal to minus 1. If we multiple minus or negative in both sides. So here, what is the value of minus cosec square theta plus cot square theta according to formula? That is minus 1. So it is in right. Minus 1. As you know, the formula of sec square theta is also 1. And minus 0.2 plus 1.2. That is also 1. And R2 are same. Sec cot square theta minus tan square theta 1.2 minus 1, 1, 1. So as you see, in this determinant, first row and third row are same. So you can write that because here R1 is equal to R3 according to property number 3. And if two rows or two columns are identical, then the determinant will be 0. So in this properties, so the above properties, so we apply these, so we get the result 0. So there is another examples. Now we take another examples, some long questions category examples, and how to apply this formula. So question number 4, I think, prove that 1 plus A 1, 1, 1, 1 plus B, 1, 1, 1, 1 plus C. It is third order determinants, and we have to prove it ABC into 1 plus 1 by A plus 1 by B plus 1 by C. So now you have to prove that. Okay, as according to question, we have to prove that. So we take LHS and we get result 2 RHS. So here we take LHS here 1 plus A 1 1 plus B 1 1 plus C. So in this question, not writing in without expanding or expanding method. So you can apply all these formula or we can apply all these method. So in this problem we apply expanding method. So how to expand a third order determinant? In previous session we have to calculate, evaluate how to determine a third order determinant. So here if we expand along R1, as you know, the sign of the third order determinant is plus minus plus minus plus minus plus minus plus. So already we discussed. So here if we expand it directly or expanding method, so here we expand along R1. R1 means the first element is 1 plus A and it was inside plus, so we can take 1 plus A. If we deleting rows and columns of the content element, so we get 1 plus B 1 plus C. Okay, and the second one is, and the sign is minus 1, so minus 1 into, if we expand row and column of these elements, so we get 1 plus C. Okay, and the third element will be plus 1. So if we deleting rows and columns of these elements, so we get 1 plus B 1. So if we calculate them, so first we have to convert third order determinant to second order determinant. And as you know as how to evaluate second order determinant, cross multiplication. Okay, so here if we cross multiply, then 1 plus B into 1 plus C minus 1 minus 1 into, if we calculate, then we get 1 plus C minus 1. Third one is plus 1 into 1 minus of 1 plus B, that means minus. So you can write directly minus 1 minus. Okay. So here 1 plus A into, if we multiply them, then we get 1 plus C plus B plus BC minus 1. Here we cancel 1 and minus 1. It also cancel minus plus 1 minus 1. So we get minus C and that is minus. Okay. So here we cancel 1 and 1 also. So here we have to multiply 1 plus A and C plus B plus BC. Okay. If we multiply 1 first, C plus B plus BC, and then 1 A, so you get SC plus AP plus ABC minus C minus C. Now you see plus C and minus C cancel, plus B minus B. So here you get the result BC plus SC plus AB plus ABC. Okay, but here in RHS, ABC into something, that means we have to take ABC common from all the elements. So if we take common ABC, if we take common ABC from BC, then we get 1 by A. If we multiply them, then we get ABC also. Similarly, if we take common ABC from AC, then we get 1 by B. Similarly, here 1 by C, that is 1. Now you can see the RHS part is also same questions. So you can write according to questions ABC into 1 plus 1 by A plus 1 by B plus 1 by C. So This is the proof, or you can say the RHS of the equations. Okay, and these questions having 6 marks according to your CSC syllabus. So now another long question category problem. Take. So here we take another examples. Question number 5, and questions is determinant of 1 1 1 A B C AQ BQ CQ, and that equal to A minus B into B minus C into C minus A into A plus B plus C. So this is the important one. So how to prove this determinant is equal to this? So here is the solution. 1 1 1 A B C AQ BQ and CQ. As you see, if we evaluate expanding method or directly expand, then you get the result of this multiplication. But you cannot find these factors only. So you cannot apply direct formula or direct expanding method. In this problem, as you see, the right hand side are the factor 4. So in this problem, we have to apply without expanding method. That means we have to apply properties. So here you can see, in previous session we have discussed, if any rows or columns are same, first we will think taking common or not in this problem. So here you can see any rows and any columns, nothing to common in this problem. So here you can see in first row all the elements are same. If all the elements are same in row, then you have to subtract column to column. If all elements, any rows are same, then you have to subtract column to column. If all the elements of column are same, then you have to subtract row to row. Okay? So here you can see in column 1, first row, all the elements are same. So row, all the elements of rows are same, so you have to subtract column to column. So here we have to take two columns. Suppose column 1 C1 minus C2, in column 2 places C2 minus, and it can be written as a cyclic order. Okay, so here in column 1 you can write column 1 minus column 2, that is 0, and that is A minus B, and that is AQ minus BQ. Okay, and in column 2 places we have to calculate C2 minus C3. C2 minus C3 means column 2 minus column 3. That means column 2 and here column 3. If we subtract, then we get 0, B minus C, BQ minus CQ. And third, column 3 same, because we have to calculate any two columns. So here column 1 and column 2, column 3 are remaining same to the given distance. Okay. So here you can see, if we apply formula means here R1 001 and R2 is also A minus B, B minus C, C, and here you can see we can formulate the formula AQ minus BQ. As you know, the formula of AQ minus BQ is A minus B into A square plus AB plus B square, and BQ minus CQ is B minus C. You can write some distance to C visibly. So here 0 B minus C into B square plus BC plus C square, and the third column is 1 C. Okay. Now here we take common A minus B from column 1. So we take common A minus B from column 1 and B minus C is also common from column 2. So here we take common A minus B from column 1 and B minus C from column 3. So here we can write 0, 1 A square plus AB plus B square. And the second row is 0, so second column is 0, 1 B square plus BC plus C square. And third is 1 C. You can write on the right side taking common A minus B from C1, that means column 1, and B minus C from column 1. You can write this right side. Okay. Now here A minus B into B minus C which is common. If we calculate, evaluate directly, then you get the result also. Okay. So here you have to expand directly. As you know, you expand along R1 because in the R1 maximum it having maximum 0. So we expand directly in R1. So the sign of 0 is 0, 0 into something 0 also, minus the sign of the second is minus, so it is minus 0 and plus 1 into. If we delimit row and column, so we get 1, 1 A square plus AB plus B square plus BC plus C square. So if we calculate them, and first we write A minus B minus C, A minus B into B minus C. Here, if we expand them, then we get B square plus BC plus C square into 1 means B square plus BC plus C square, minus if you multiply A square plus AB plus B square into 1, that means we get the result A square plus AB plus B square. And must be right in bracket form because here in previous negative sign. So it must be right in bracket form. Okay. Now here we have to calculate and get the result. Okay. So here A minus B into B minus C. If we integrate the bracket, then we get B square plus BC plus C square minus A square minus AB and minus A square. So here it can be arranged A minus B into B minus C. Here you can write B square minus, or we can write B square minus A square. Sorry. As you compare the right hand side, you already find A minus B and B minus C also. Okay. So here is C minus A. So you can write C square minus C square in first, and the remaining part is. And now you can cancel B square and minus B square also. So here B square minus C square write firstly and then BC minus A. Okay. So here A minus B into B minus C. As you see in this bracket having 4 terms. So we take or we apply first 2 terms. Formula, that means we can apply A square minus B square form. So we can write C plus A into C minus A. Okay. And the last 2 terms having take common B from these 2, so we get C minus A. So here A minus B into B minus C. In this expression we take common C minus A only. So we get C plus A plus B. So it can be written as A minus B into B minus C into C minus A into A plus B plus C. And that is the solution. Or we can write it that root. So in the session we have discussed how to apply properties of determinant. So have a nice day.